Hello everybody. Let me just get this into presentation mode and see, there we go. How is everyone doing? It's a beautiful day outside. Hope you're getting out and having some fun, but not so much fun that you're not doing your homework. So let's jump right into it, okay? Today we are looking at quadratic equations, which I am calling bending the line. We're going to be looking at curves that we see all over the natural world, and in this case, this beautiful half pipe here. So before we get into bending lines, let's just review the line itself. So if you'll recall, the equation for a line is y equals mx plus b, where y is our dependent variable, which is on the y-axis, or the vertical axis. M is the slope, which is our rise over run. And x is our independent variable, which is on the horizontal axis. So remember, our rise over run, it's our y, which is the vertical, the rise, over our run, which is the x, which is the horizontal. Don't forget b, which is the y-intercept, and that's where the line crosses the y-axis. So that's given by the coordinate point 0, comma, whatever your y-intercept is. But remember, so let's just review. For graphing the line, I'm just using an equation here, y equals 1/2 x plus 4. So we have our m value here, which we know is our rise. So this line is going to go up 1 and over 2 between the points. And then we know that it's going to cross our y-intercept here at y equals 4. But even if we didn't know that, if we knew nothing about a line, we could always come back to our trusty table here and just plug in some points, plug in some of our independent variables here, and then find what the corresponding y values, and then graph it and see what the function looks like on a graph that way. So let's do that now. Here we have given our independent variables x, which I just chose some random points. Remember, to graph a line, you only need 2 points. So we're going to be finding our dependent variable, which is our y values. And then how do we do that? If you recall, all you do, take whatever number it is, so in this case -8, we'll plug that in here and we'll solve the equation for y, and that will be the corresponding y value. So if you already remember how to do this, just pause the video now, fill out this table, and see if you can't graph it. But, well, there we go. But if you do need some help, I'm going to run through a couple of examples really quick and help you get started filling out this table. So for x equals -8, what we're going to do is take our equation, but where we have our x variable, we're going to plug in our -8. So here we go, y equals 1/2 x times -8 plus 4. 1/2 times -8 is equal to -4, because remember, a negative times a positive is a negative. -4 plus 4, same thing as 4 minus 4, is equal to 0. So our y equals 0 is what I'm going to plug into the table with the -8 value. Go over one more with you. For x equals -4, same thing. We're going to plug it in here, our x value. So 1/2 times -4 is going to be -2. -2 plus 4, or 4 minus 2, same thing. It's going to be y equals -2. And so that is what I'm going to add to my table here. It's corresponding to that x equals -4. And now I want you guys to stop the video, because I'm going to keep going. But I want you to go through and do that for 0, x equals 0, x equals 4, and x equals 8. See if you can't do it. Get into practice. Fill out the table. Okay. Hopefully you did that. And hopefully your numbers come out. So your x value corresponds to a y equals 4. When your x equals 4, your y is going to be 6. And for x equals 8, your y is going to be 8. If you got any of these wrong, or you're struggling with this at all, don't stress. We can talk about it in class, but for now, let's go on to graphing. So here we have the graph of this line. And again, if you didn't know that your y-intercept was 4 by looking at this equation, which we see it is, and if you didn't know what the slope what that meant, which means you're going up 1 and over 2, all you would have to do is pull out your table, find a couple coordinates, and plot it on the line, and then draw your line through it. Okay, so that was just some review for drawing lines, but now what we want to look at is how we can turn that line into a curved line, or what I'm saying is how we can bend that line. So we want to figure out if this equation, y equals x, it corresponds to a graph that is a straight line, what does y have to equal in order to make that line bend? Okay, that's kind of our guiding idea right now. And so we're going to do this in the same way that we do lines, only this time we're going to look at a function that is now squared. So this y equals x squared, and because this isn't linear, this doesn't fit our linear equation, we don't really have anything to go on. We're going to have to go plot some points and take a look at it. That's why we are investigating, because we don't know what the slope is, we don't know what the y-intercept is, so we're just going to have to figure that out. And so we're going to do it, like I said, the same way we would do it for a line. I'm giving you some independent variables, our x values, and we're going to plug them into this equation, and we are going to find the corresponding y values. I will help you out for the first couple. So for x equals -2, we plug it in. So again, here's our x. In this case, we're plugging in -2. So we get y equals -2 squared. Remember, that's in parentheses, so this is the same as -2 times -2. And we remember a negative times a negative equals a positive. So y equals positive 4. Y equals positive 4. That is what we're going to plug in to this table, just like with a line. We're going to keep going. So now for x equals -1, same thing. Plugging it into the equation. Y equals -1 squared. So we have negative times a negative is a positive. 1 times 1 is 1. That's what we're going to plug in here. Okay? Now, pause the video, do that, same thing, but for the rest of these values, and then we'll go on to plotting these points, seeing what this looks like. Okay. So again, your table should look like this. If it doesn't, no panicking. We can talk about it. But for now, we're going to plot these points. Alright, so here's my graph. It's exactly the same as the graph of the line. We're going to plot the points exactly the same. So my first data point that I'm going to put on here, coordinate point, is going to be -2, 4, plotting that point right there. Go over 2, up 4. My next one, -1, 1. We have 0, 0. Over here to 1, 1. And then up here, 2, 4. Again, each of these points corresponds to these points here. And just plotting in those points, we can see that now this y equals x squared is not giving us a line. It's giving us something that looks curved. You may think, oh, maybe it's 2 lines. It is not. And if we plotted more points, you would see that. So if you went through and maybe plugged in -0.5, saw what came out, plotted that point, maybe another 0.5, maybe you went out and plugged in a 4, and you can see that that would be 16. Same over here. What you'll find is that these aren't 2 straight lines, they're actually curved, and this is one big curve, just what we were looking for. Alright, and we found that just by plotting these points here on this graph. And so let's compare. So here we have our linear function, y equals x, and we plot that on here, no curves, just a straight line, and that corresponds to these points that we plugged in here and to find. When we come over here to our x squared, we now see that when we plug a negative into this function, it's spitting out a positive. Negative here, spitting out a positive, whereas here it was giving us negatives. So that's why we dip into this quadrant. But here, once we get to 0, we end up turning back up because of that squared value. So that is curving our line, which is exactly what we were hoping to do. Okay, so this was just an introduction Don't panic. I don't want to rush into this too much. But the curved line, what we call that, we call it a parabola. So parabolas are curved lines. They can be up, they can be down. As you will see with this little animation, if you watch it long enough, it turns down when we have a negative. And these parabolas, they're represented by a general equation, which is y equals ax squared plus bx plus c. We're going to get into this more in the future. I just want to give you a little priming before we get there. All right? So go ahead, have a good day. I will see you next class.